This is going to be another pretty short video because dependent t-tests are really easy to understand. Okay, so we're just going to do a short video here and then I'll have another video with some examples. So a dependent t-test, this goes on with the within groups designs that we just talked about. So you might hear these called repeated measures, related samples, dependent samples, paired samples, matched pairs. These are all different terms to mean scores that have to stay paired together. They have to stay attached to each other. So here's that decision chart for how to know which test to run. So let's start at the top. Are you examining relationships between variables or examining the difference between groups? So in a dependent t-test, we are looking at the difference between groups. So we go over here. Are the participants being tested more than once? In between groups designs, we went over here to no. But now we're going over here to yes. We're in a within group design. Okay. Now this test or this chart is not all inclusive. You don't just use a dependent t when it's the same participant being measured twice, like it says here. You use it whenever it's important for two scores to stay together. Remember the paired samples. So maybe we're measuring spouses or partners. Maybe we're looking at a parent and child or siblings. So whenever scores have to stay locked together, then we go over here to yes. Okay? Then we say, how many groups are you dealing with? If you're just dealing with two groups, you can do a dependent t-test. If you're dealing with more than two groups, that's what we'll cover next. But today we're staying over here. We're just looking at two groups for a dependent t-test. So it could be just two people who are being tested or one person who's being tested twice. Okay? Other than that, it's not a whole lot different from an independent t-test. So in SPSS, you need three variable columns. The first is the participant ID column. You don't technically need this. SPSS will run without it, but it helps anybody who's trying to read your data understand what's going on. So you need one column that's just your participant's ID number. It could just be 1, 2, 3, 4, 5. It could be names. It could be a code, whatever. The second column should be whatever test 1 is. If you're doing pre-test, post-test, then it could be the pre-test. And then a third column for test 2. In a independent T, we put everything, all the scores in one column and then had a second column that indicated their group. For a repeated measures, it has to be done a little bit differently. We need each test to be in its own column because remember, all the rows are a participant. Every row represents a participant. So since the participant is taking the test more than once, we need a column for each time they take a test. And this keeps everyone's scores locked together. It keeps it as the dependent T. We're dealing with a t-test. We have to use Cohen's d. And this formula is much easier in a dependent t-test than it was in an independent t-test. All you do is you subtract the means from your two groups and you divide it by your standard deviation. It's really, really easy. You can use your output to calculate Cohen's d. All you have to do is use this table here that already has subtracted the means between your two groups and gives you that, and then divide it by the standard deviation. You can also use the calculator I already gave you and it should do this for you. But remember the guidelines. A 0.2 is weak, a 0.5 is moderate, and a 0.8 is strong. If we take this number and divide by this number, we end up with 1.56. So that would be very strong effect. So Cohen's d is really easy to hand calculate, but you can use an online calculator if you want. So when it comes to reading the results, you want to come down to the table that says paired samples test. Okay, it gives you the confidence interval. Your book likes to report confidence intervals. Here it is. But what I care about is here. It's the t, the degrees of freedom, and the significance. That's all we care about, just these three little numbers. So in this case, the t was significant. So when it comes to reporting the results, we might do something like this. We analyze these data using a one-tailed paired samples t-test. You have to give whether your hypothesis was one or two-tailed, and you need to say that it was a paired samples t rather than an independent t. Children rated their confidence in a woman's object identification differently based on her level of attractiveness. So we said that there was a difference, and then we give the t here with the degrees of freedom, which was 10. Then we say what t equaled from the previous table. P is less than 0.001, and then we reported a 95% confidence interval. You don't have to do this, but a lot of people like these. And then the Cohen's d is equal to 1.56. When children believed information came from an attractive woman, they rated their confidence in the information higher. Gives mean, standard deviation, and n. Then when they thought the information came from an unattractive woman, mean, standard deviation, n. So the first thing you say is whether or not there's a difference, and then you say where that difference is. Which group was higher, which test was higher. Okay? That's really all there is to it. A good thing for a t-test is to give a bar graph with the confidence intervals. That's really nice to see, but since you're not going to have access to SPSS, you won't be able to generate these graphs, so don't worry too much about them. But in the next video, we're going to go through a couple of examples, and I hope that will really help dependent t-tests make sense to you.